Hello and welcome. Today we're reviewing a typical cost estimation built in Azure's pricing calculator. We'll compare that cost estimation to a real-world example using real data to model the expected costs when leveraging CloudJumper's suite of resource scaling technologies included in CWMS. These features effectively put the scaling of VM resources on autopilot. In this scenario, we have 800 named users with an average peak concurrency of 90%, meaning that our environment will have capacity to support up to 90% of those 800 users. We also have an off-peak concurrency of 5%, meaning there'll be resources available for up to 5% of those 800 users to connect on evenings and weekends. This pricing calculator assumes that there'll be 220 peak hours per month and 510 off-peak hours. The yellow graph to the left illustrates this workload schedule, with 5% available as a floor across the bottom, and 5 columns, one for each workday, representing the peak on time. At CloudJumper, we have access to millions of data points across thousands of real-world customer deployments, and we know that users don't log in and out at precise times every day. In fact, through analyzing 35,000 of these data points, we are able to draw an estimated active user session curve. When we apply that over the top of the graph, we see that the calculator, which is built to illustrate how you can save money on compute using basic scheduling scripts, misses the nuances of real-world experience. It does this for simplicity and to reflect the reality that scheduled scripts are not likely to be implemented in a complex way, as the added overhead and ongoing auditing and tuning make that not worthwhile. There are a few reasons the estimate from the Azure calculator misses the mark. First, there are times when the amount of resources running, and thus the costs incurred, exceed the requirements. In fact, it must always exceed the requirements to account for natural deviations in usage patterns. This is because, as a static scheduled process, there is no awareness of the current situation. It must be configured to be as high as is even somewhat likely. This is a similar concept to the classic comparison of a capital hardware purchase and pay-as-you-go cloud infrastructure, but on an hour-by-hour basis. Each day, the pre-scripted schedule effectively procures resources for that day's maximum capacity, just in case it's needed. This creates wasted spend, as indicated by the yellow area on this graph. With a static scheduled approach, there isn't much you can do to get efficient on this point. You can reduce the peak concurrency, but only by increasing the risk that at some point a user will be denied access to resources or experience performance degradation due to over-provisioning. There are other times when the available resources are not sufficient because the schedule is too rigid. The Azure pricing calculator assumes this environment is in its peak on state for 220 hours per month. This works out to 50.63 hours per week. However, because humans are variable, for example, some arrive early, some work late, still others can work on the weekends to catch up or get ahead, the beginnings and ends of each day have times when the scheduled off-peak state does not offer enough resources. The same is true midday on Saturdays. With a static schedule, you can fix this by increasing the time window that the environment is set to peak on, and/or increase the off-peak concurrency percentage. Effectively, that means widening the windows for each column and raising the floor to cover the weekends. We've found the most efficient is a balance between the two, where we increase the off-peak concurrency to 10% to cover the weekends and expand each weekday by about 3 hours. Now you've set the peak on time to 65 hours per week, as opposed to the estimated 50.63 we originally had. And the off-peak hours now cost twice as much, since we've moved them from 5% to 10%. So the costs have increased as compared to the original Azure estimate, but we have an environment that's more likely to provide enough resources for real-world usage patterns. There's still a risk that unusual patterns will hit those scheduled limits, but we've significantly reduced that risk with these adjustments. The Azure calculator assumes usage patterns are static, or that your staff will reactively evaluate and adjust these schedules on an ongoing basis to keep them aligned with user behavior. Since CloudJumper's CWMS includes functionality that automatically aligns resources with usage in real time, we can make sure that your resource consumption matches your resource requirements, no matter the shape of your active user session curve or how frequently that varies. Now that we've adjusted our model to more accurately fit real-world experiences, we can accurately compare the differences between a scripted static schedule and the automatic adjustment of virtual machine resources using CloudJumper's CWMS, effectively putting this on autopilot. The results we see here are typical. We're reducing compute costs by about 47%. This is visually represented by the yellow area on the graph. CloudJumper's CWMS automation takes the total cost from about $6,500 to just under $3,500, even when we're comparing against a fairly well-tuned static scripted schedule. The benefit is not only that we're saving costs, but that this system dynamically adjusts the environment to meet your resource needs at all times, practically ensuring that end users always have resources available and don't experience performance degradation due to oversubscription, without the need to simply throw excess resources at the problem. Thanks for watching this video. I know that was a lot to cover. For more information, check us out at cloudjumper.com.